All right, 3.8, page 170, 1 through 23, every other odd, which ends up being just 1, 5, 9, 13, 17, and 21. So we don't even reach 23, but that's okay. All right, and I also have out my notes because I didn't memorize these, and I'm going to use my little cheat sheet, the inverse trig derivatives. Okay, so number one, we need to find the derivative of y equals cosine inverse of x squared. Okay, so first of all, we have on the inside an x squared. So we're going to have to use chain rule. Okay, so we first need to take the derivative of the inside, which is a 2x, times the derivative of the cosine inverse. So cosine inverse is this one, -1 over the square root of 1 minus x squared. Whatever is inside the cosine is what we plug in for x. So this would be -1 over the square root of 1 minus, my x is an x squared. So it's x squared squared because I have to plug in an x squared for x and it's being squared. So it's x squared squared. Okay, which equals, I have a 2x times a -1, so that'll be a -2x in the numerator there. And in the denominator, I will have 1 minus x squared squared is x to the 4th. And that's it. Number 5, we have to differentiate y equals sine inverse of 3 over t squared. Well, because the inside here is a fraction, I'm going to have to use the quotient rule because we have to take the derivative of the inside. Okay, so I'm going to have y prime equals low, which is t squared, low d high, derivative of the high, derivative of 3 is 0, minus the high times derivative of the low, all over low squared. So t squared squared would be t to the 4th. Now this is all being multiplied times the overall function, which is the sine inverse. Where's my cheat sheet? Sine inverse, arcsine, is 1 over the square root of 1 minus x squared. So I'm going to plug in, or times, a positive 1 over the square root of 1 minus x squared. Well, my x is a 3 over t squared squared. Okay, so I'm going to have to clean that up. I'm going to switch colors, so that's a really bright color. And so I have y prime equals, anything times 0 is 0. And this will be a -6t over t to the 4th. So this t will cancel, leaving me with 3 down here. So I will have a -6 in the top, because -6 times 1 is -6. All over, I'll have a t to the 3rd out front of the radical. And it'll be 1 minus 3 squared is 9 over t squared squared would be t to the 4th. Okay, that's all under that radical. Well, I want to simplify what is in that radical. So I want to get a common denominator with the 1 and the 9 because I see two things in there that are perfect squares. So to get a t to the 4th here, I'm going to need to multiply top and bottom by t to the 4th. Okay, so this will be -6 over t cubed times the square root of t to the 4th over t to the 4th minus 9 over t to the 4th. So I have the common denominator of t to the 4th, and in the top I will have t to the 4th minus 9. That way I cannot have a fraction in there. So this whole thing is underneath the radical, so you can separate it. You can have the square root of t to the 4th minus 9 over individually the square root of t to the 4th. And t to the 4th is a perfect square. That's what's so lovely about it. So we'll have -6 over, let's see, we have t to the 3rd times, let's split this to t to the 4th minus 9 over the square root of t to the fourth. So yeah, I have a fraction times a fraction in the denominator. And we know that the square root of t to the fourth is t squared outside of the radical. And I can cancel out these two t's with two of them from there, leaving me with 1. So then my final answer is -6 over t times the square root of t to the fourth minus 9. So anytime you have a fraction underneath the radical, you will need to simplify it like that. And there it is. It's not too bad, but manipulating those fractions can be a bit cumbersome, I know. All right, number 9, x of t equals sine inverse of t over 4. I messed up over there, so I crossed that out. We're finding the velocity. That's what they are asking for. So that means we need to find the slope, which means we need to take the derivative, of course, because that's what this lesson is about, differentiating the inverse trig functions. So x prime of t is going to be, well, we have something on the inside there, so we're going to have to use the quotient rule and chain rule. So quotient rule on this, well, low d high. So the low is 4, derivative of the high is 1, minus high, derivative of the low is 0, all over low squared. 4 squared is 16. Okay. Times the overall, so this was the quotient rule, and now because we are taking the derivative overall, we did the inside, now we're working on the outside, so sine inverse. And on my little cheat sheet, arc sine is 1 over the square root of 1 minus x squared. So this would be times 1 over the square root of 1 minus, the x is a t over 4, so t over 4 quantity squared. Okay, so same type of thing that happened in number 5. We're going to be dealing with here as well. Okay, so you already know what kind of simplification processes we're going to see. This is 0, so I basically have 4 over 16. Well, 4 goes into 4 once, 4 goes into 16 4 times, so this is basically a 1/4 times 1 over the square root of 1 minus t squared over 4 squared is 16. Remember, we need to get a common denominator so that we could split that fraction. So the denominator is going to need to be a 16, but that means I need to multiply the top by 16. 16 times 1 is 16. Let me zoom in a little bit so you can see that better. Equals, so I'm going to have 1 in the numerator, 4 on the outside, and I'm going to have the square root of 16 minus t squared all over the square root of 16. Well, we know what the square root of 16 is. The square root of 16 is 4. So this is going to be a 4, which means these 4s are going to cancel. So that means my answer then is just 1 over the square root of 16 minus t squared. Oh, I forgot to put at what t value. They wanted us to find the slope at a specific t value. It was at t equals 3. My bad, I forgot that. That was in the instructions on this problem. So now we're going to take that and plug it in for t down here so that we can find the slope. Because how can we find the slope without plugging something in? Slope formula, though. So 1 over the square root of 16 minus 3 squared. Well, 3 squared is 9. 16 minus 9 is what, 7? So this is just 1 over the square root of 7. And that would be the slope at t equals 3. Okay. And then number 13, we have to differentiate y equals secant inverse of 2s plus 1. So we're going to have to take the derivative of the inside. We have to use chain rule, and then derivative of the overall. Okay. So y prime equals, the derivative of the inside would be a 2 times the derivative of secant inverse. So I'm pulling out my cheat sheet. Secant is 1 over the absolute value of whatever the x is times the square root of x squared minus 1. Okay, so that's going to be 1 over the absolute value of my x is this, the 2s plus 1. It's in the absolute value times the square root of the x squared, so it'll be 2s plus 1 quantity squared minus 1. Okay, and there it is. Yeah, it looks funky, but it will be okay. All right, so we have some simplifying we're going to have to do, like that 2s plus 1 quantity squared. We need to simplify that. That means we need to multiply it out, FOIL it out. Okay, so we're going to have 2 times 1, because that's going to be in the numerator, would be 2 over the absolute value of 2s plus 1 times the square root of, this ends up being 4s squared plus 4s plus 1, and then there's that minus 1 on the end. Okay, and we got to clean that up a little bit because 1 minus 1 cancels out to nothing. And so then we'll have missing something. I figured it out. I'm good. I'm good so far. I haven't made a mistake. So I have 2 over the absolute value of 2s plus 1. It's just in my own notes, I skipped some steps, and I'm irritated at myself for doing that because then I got lost. And okay, so this is what I did. 4s squared plus 4s is what's left. And obviously there's a common factor of a 4 in there. So I'll have s squared plus s when I factor out that 4. And can't we take the square root of 4? Because 4 is a perfect square. So we can still do that. We simplify this further. So we'll have 2 over the absolute value of 2s plus 1. The square root of 4 is a 2, so 2 gets to come out of the radical, and then we're done with that 4. And s squared plus s is stuck inside. Okay, and then last but not least, these 2's cancel. So when something cancels out like that, it turns into a 1. So 1 over the absolute value of 2s plus 1 times the square root of s squared plus s. And that is the final answer. So yeah, that was kind of a yucky problem. But like I said, these are not the greatest, but it's something that you have to learn. Okay. All right, next problem. On the back, moving all my pens everywhere. All right, number 17. Need to differentiate y equals secant inverse of 1 over t, and t is between 0 and 1. Okay, so that means t is a positive number and it's a decimal. It's between 0 and 1. Okay, all right, let's start doing this. So y prime equals, well, I've got the inside here, 1 over t. Now, it's easier to write this as t to the negative 1 power, because then all I have to do is power roll on that when I take its derivative of the inside, because I have to use chain rule here. So the derivative of t to the negative 1 would be a negative 1t, and then subtract 1 from that exponent to the negative 2. Okay? Times the derivative of secant inverse. So I'm pulling out my cheat sheet. There it is right here. It is 1 over the absolute value of x times the square root of x squared minus 1. Okay. So this will be times 1 over the absolute value of x, which is our 1 over t, times the square root of the 1 over t squared minus 1. Okay? All right, so this is where this interval comes in handy, because absolute value is supposed to ensure that it is positive, because it measures distance, and distance is never negative. But if t is between 0 and 1, that means it is a positive number. So I don't need the absolute value on there anymore. Okay? And I'm just going to multiply straight across. So I have a negative 1t to the negative second. all over. I have a 1 over t in the denominator, taking those absolute value brackets off. Square root of 1 squared is 1 over t squared is t squared minus 1. Yeah, we have a fraction underneath that radical, so we're going to have to do those steps to simplify and get rid of the fraction. So I need to get a common denominator, and it's going to have to be a t squared, which means I have to multiply the top by t squared. Good thing it's a 1 because 1s are easy. Okay, sorry, that yellow pen doesn't look very good. I'm going to go over it with the blue. It's a t squared over a t squared. Okay, so that's going to equal negative t to the negative second power over 1 over t times, now I can split the fraction. I'll have 1 minus t squared in the numerator over the square root of t squared in the denominator. And we know what the square root of t squared is because it is a perfect square. So we'll have negative t to the negative second power over 1 over t times the square root of 1 minus t squared. The square root of t squared is t. Okay, so I'm going to put that t out front and make it a 1 over t squared. Okay, so here we go. Next step. I'm going to write this over here. Negative t to the negative second power over t times t is t squared, so 1 over t squared times the square root of 1 minus t squared. Okay, so you're probably wondering why I waited to do this. I got to drop it like it's hot. And when I bring it down here, it'll be a t squared, so these will cancel out. So all I'm going to have is a negative 1 in the numerator over the square root of 1 minus t squared. And that's simplified nicely. Yeah, those simplifying steps with the radical and the fraction are, yeah, they're cumbersome, but gotta do it. All right, number 21, last one. So we have y equals tangent inverse of the square root of x squared minus 1 plus cosecant inverse of x, and x is greater than 1. Okay, so let's start taking the derivative. So we have tan inverse of x, and this is what it's of. And I want to rewrite that because we're going to have to use chain rule because we're going to have to take the derivative of the inside there. And let's rewrite this as x squared minus 1 to the 1/2 power because it's easier to do the derivative when we're dealing with that. And I'm going to have to use the chain rule on that. So that's going to be a little complicated. So I'm going to wait to do it. So I'm going to have to take the derivative of x squared minus 1 to the 1/2 because I'm going to have to use chain rule on the chain rule pretty much, times the derivative of the overall is tangent inverse. So if I pull out my cheat sheet and look for tangent inverse, I get 1 over 1 plus x squared. So times 1 over 1 plus x squared. Okay? Plus cosecant inverse of x. Okay? There's nothing fancy. It's just an x. So it should be just the way it is in the little cheat sheet. So negative 1 over the square root of 1 minus x squared. Wait, I gotta look for cosecant. I looked at the wrong one. I was like, wait a minute, that's not what I have on my paper. Here it is. Cosecant negative 1 over the absolute value of the square root of x squared minus 1. That almost became a mistake. Okay. And now we just got to clean this up. So they give us this interval. X is greater than 1. So if x is bigger than 1, doesn't that mean that x would be a positive number then? Yeah, any numbers bigger than 1 are positive numbers, 2, 3, 4, 5, 6, 7, 8. So we're good there. Okay, so I will get to lose those absolute value brackets. I won't need them because I know that x is greater than 1. All right, let's continue on. we need to do the chain rule on this bad boy right here. So the derivative of the inside is a 2x times, we have to drop that exponent down, well, 1/2 times the stuff on the inside, and then subtract 1 from that power. 1/2 minus 1 is a negative 1/2. Okay, and this is all times the 1 over 1 plus x squared, and then plus negative 1 over, I'm going to lose the absolute value brackets, x squared minus 1. Okay, and let's clean it up. There's going to be some things that can cancel, like these 2's. Okay, and we can drop this like it's hot and convert it back to a radical. So we'll have y prime equals, I will just have x up there in the numerator, over, we'll have the square root of x squared minus 1 times 1 over 1 plus x squared. All right, I had to pause for a second because I forgot something. I messed up, but it's fixable. When I did the derivative of the inside, I waited to do that. That was fine. The derivative overall was 1 over 1 plus x squared, but my x squared is this. So I should technically have 1 plus x squared minus 1 to the 1/2 squared. And that's where I messed up because I forgot to do that. Common mistake. So those cancel, so that's just an x squared minus 1. 1 plus x squared minus 1, the 1's cancel, so that's just a 1, it's just an x squared. Okay, so this is just an x squared. So I was like, what is happening here? So I had messed up there, but it's okay, I'm human, I make mistakes too. Just because I'm the math teacher doesn't mean I slip up. I'm not perfect by any means. I never will ever claim to be perfect. Okay, nor will I expect you guys to be perfect either. I mean, I'm just testing you on the concepts, but I'm not expecting you all to be perfect. Okay, all right, so which is why tests are graded so easy in calculus. All right, so now that we have that taken care of, I know that when I multiply this, I will have y prime equals x over, we'll throw the x squared out front, x squared minus 1 plus negative 1 over x squared minus 1. These are almost the same denominator. So we can make them the same because look, I can cancel out this x and take away 1 from down here, and now they're the same. Okay, but watch this. 1 plus a negative 1 is 0 all over x, square root of x squared minus 1. What's 0 divided by anything? 0. So that means that y prime, the derivative, is 0. So the slope is 0. And that's it.